Jai Hind. Myself, Dr. Ajay Pratap Singh. I am Associate Professor in Department of Mechanical Engineering at Kumar Garg College, Ghaziabad. And I teach here the theory of machine in the B.Tech third year, and the subject code the BME 603. And previous lecture I've discussed the different type of what is the theory of machines, what is the kinematics, dynamics, statics, kinetics, and the kinematic pair, and then again the types of the motions I have discussed in the previous lecture broadly. Now continue in this other further in this further lecture. So these are in the combination of this continuation of this, you can say that we can today cover the kinematic chain, types of the joints in the chain, you can say the degree of freedom, number of degree of freedom for the planar mechanism, then application of the Kurzbach criteria, and the kinematic pair, and the kinematic pair types of the, we can say we can discuss the kinematic pair and all these details. So we can go one by one. So we can say the kinematic chain. Uh, Earlier we have discussed the kinematic pair, the two link is connected. So pair means the connection of the two links. So that, and the chain is the combination of different linkage, and then the first link is connected to the last link. So you can say when the kinematic pair are coupled in a such a way that the last link are joined to the first link to transmit the definite motion, we can say that the kinematic chain, and we can say that is the completely or the successfully constant motion is called the kinematic chain. If we can say if each link is assume uh, the form of two pair with the with two adjacent link, then the relative between the number of pair that is represented with the P and the forming of the kinematic chain, and to number of link you can the L. So we can express the form of the equation L equal to 2P minus 4. And another relative between the number of the link and the number of joints, so the which constitute the kinematic chain, and given by the expression j equal to 3 by 2 L minus 2. So I'll on the basis of that we can find out what is the link and how the losses of this the pair. So losses of this joint. So we can, on the basis of that we can find out the kinematic chain. Suppose these are the three cases, right? LHS, if these equation L equal to 2P minus 4 or J equal to, J is the number of joints, you can say equal to 3 by 2 L minus 2. J is the number of joints in the terms of the binary joint. So I'll discuss the different types of joints also. So if these equation three equation LHS is greater than RHS, then in that case the log chain LHS equal to RHS, LHS is greater than, less than, and greater than. So in that case there are three conditions. Suppose LHS is less than RHS, then what is the log chain? LHS is equal to, and LHS is greater than RHS. So in that case that's the constraint chain. So there are three figures, that is one link is there. So we can join L equal to 2P minus 4, right? So here you can see that is L number of link equal to 2P, 2 into P, 1, 2, 3 minus 4, right? So we can find out that is 3 equal to 6 minus 4 equal to 3 equal to 2. So what it means? Left hand side is maximum, right? Left hand side equal to maximum and right hand side is the lower. So in that case this equation is satisfied, so that called the locked chain, right? So we can use this formula and find out. So types of joints, you can say different types of the joints in the chain, that is the binary joint, tertiary joint, quaternary joint. So binary joint, you can say when the two links are joined in the same connection, and the joint is known as the binary joint. So for example, suppose these are the kinematic chain, you can see here in this figure. So that is the kinematic chain with all the binary joint, that is the point number kinematic chain. These are the first link. There are 4 links. You can count link 1, 2, 3 and 4. 1 is connected to 2, 2 is connected to 3, 3 is connected to 4 and 4 is connected to 1. So these are, you can say, that is the kinematic chain is the form, right? The last link is connected to the first link, and point A, B, C, D, and their point A is the 2 link is joined, point D is the 2 links is joined, point C is the 2 links is joined, and point 3, point B at the 2 links is joined. So AW Kelvin may be used, you can say that the one equations J plus H by 2 equal to 3 by 2 L minus 2, where H, J equal to number of the binary joints, H equal to the number of higher pair, and L equal to number of link. If in case of higher pair is 0, so the equations becomes J equal to 3 by 2 L minus 2, right? These are the equations. You can see here. So in case if the higher pair equal to H equal to 0, so you put the value of H equal to 0 in the equation 1. So equation becomes 1 equal to J equal to 3 by 2 L minus 2. What is the tertiary joint? When the 3 links are joined the same connection, the joint is known as tertiary joint, and it is equivalent to the 2 binary joint. It means कि one binary joint, one tertiary joint equal to 2 binary joint. Right? One ternary joint equal to the 2 binary joint. So you can see here that is the kinematic chain having the binary and ternary joint. So you can see here that the point number A, the link 1 and 6 is connected, but you can see that the point number E and point number C, right? Suppose you can draw the figure here. Right? A, B, C, D and E, right? This is the link number 1, 2, A to B 1, B to C 2, C to D 3, D to E 4, and E to A is the 5, suppose, right? So one link added in the point E to C connect here, that E is connected to C, right? So here you can see that is 3 link is connected, 5, 6 and 4 is connected to point T, and D link number 6, 3, 2 is connected to point number C. So you can say that is the point number E and C is the tertiary joint. Also tertiary joint, you have seen the formula J equal to 3 by 2 L minus 2. AW Kelvin has given the equation. So always all the tertiary joint or quaternary joint is convert, ternary joint and quaternary joint convert into the binary joint. So we must have convert to ternary joint to the in terms of binary joint. So one tertiary joint equal to binary joint, because that the formula is here in terms of binary joint. Now we can say the joints of the ternary joint, quaternary joint, next point. So when the 4 links are joined in the same connection, the joint is called the quaternary joint, and it is equivalent to, you can say, the one quaternary joint, we can say equal to 3 binary joint. 1 Q U A R T. One quaternary joint equal to 3 binary joint, right? So always use. So you can see here in the figure, number A, the log chain having the binary and ternary and quaternary joint. So you can see here the point number, we have find out here where is the quaternary joint in this figure A. So here that is, you can say the AB link in point A, 1, 2, 3. So 1, 3 and 11 is connected, the 3 link is connected, tertiary joint. Here 1, 2, 3 is the tertiary joint. Here point D is the binary joint, right? Here 7, 6, 7, 5 and 6 is connected tertiary joint. Point F, 6, 8 and 9 is the tertiary joint. But you can see here that the point number G. Point number G, at point G you can see here 11, link number 11, link number 10, link number 8 and link number 7 is connected. So we can see here that is the quaternary joint. You can see the point number C here. The link number 2 is connected, link number 9 is connected, link number 10 is connected, link number 3 is connected. At the point you can see that is called the quaternary joint. The 4 link is connected at that point. Point C, and again you can see point C and G, right? So point C and G is connected as the point C and G is point the quaternary joint. But in case you can see that the link between G and C is removed in this figure, right? In the figure number 2B. So we can say here that for the removing of the link number 10, the link G to C is connected by the link number 10, you can say. So we removing this link in the kinematic chain having the binary and tertiary joint. This is not a part of the locked chain. Locked chain means the LHS is always greater than RHS. There are some other we can say that is the binary link and ternary link. So you can see the point number 1, link 1, 2, 3, 4, 5 to point A. Here you can find out A, B, point C and D. So that is the 2 link connected here, then 2 link connected here. So we can say that is the binary joint. Right? Here you can say that a ternary link in this case. So these are tertiary link. Here is the quaternary link. The solid body is the quaternary link is there and ternary link. Now come to the degree of freedom. Degree of freedom, you can say there are, you can say these are the body in place in this coordinate x, y, z, and the degree of freedom you can describe in terms of the unconstant rigid body moving in the space can describe the following 2 independent motion. One is that is the translation motion along any 3 mutually perpendicular to the x, y, z. So x, y and z, these are the body placed in the space. So there are 3 translation motion around this x and y, z. X, y and z. There are 3 motions. And second, there are 3 rotary motions, that the rotational motion about this axis, that is right. So there are 2 type of, you can say, the motion is possible. One is the translatory motion and second is the rotary motion. So we can say that the independent motion is possible, right? So thus we can say the rigid body possesses, you can say the maximum the degree of freedom, you can say the 6 degree of freedom for the rigid body, and the connection of the link with another imposed to certain constant and relative to motion, the number of, you can say the restant can never be 0 or the 6 joint become you can the solid body. So the degree of freedom we can say define for the number of independent relative motion, both translation and rotational can be translator pair can have. So degree of freedom you can say degree of freedom maximum in case of rotational and using this the translation motion. So degree of freedom you can say number of freedom 6 minus number of resistant, because you can fix up resistant is applied, then degree of freedom is losses. So degree of freedom of planar mechanism, one of the most important concern in this number of degree of freedom. So also called the movability and of the mechanism, and it is defined the number of input parameters, usually we can the pair variables, and which must be independently controlled in order to bridge the mechanism into the useful engineering purpose. And it is possible to determine the number of degree of freedom of the mechanism and directly from the number of links and the types, the number of joints. So you can see that the 4-bar chain And then there is the 5 bar chain. So here that is a theta. One theta is here, one theta 2 is also there. So what is the number of motion is there? So we can calculate one by one in terms of using this formula. So suppose for the degree of freedom in the planar mechanism, we developed some relationship in general considered from the link A. Suppose you can see here that is the one link, CD is the one link is here, and we in the xy plane, that is suppose yox is the plane, that is the place in one link, and the point P, we can find out the point P in the xy direction. So we can say that is point is the x and y. So to find out the coordinate x and y here, right? And these, if you draw this figure here in the links of the planar mechanism, so we can find out like that ki CD is inclined as a theta, right? This point is the D and come to point A. So these are C and these are B. You can see that is the B, AB link here, and this is CD link. So if you connected to point D is connected to A, so this inclination angle is the theta, right? So we can see here that if suppose if DC link is freely here, this can be move in the x direction or the y direction, right? So this link is moved like upward direction or the downward direction. But if this link is fixed up with the point A, that this CD link at the point is moved to the come to the x axis or the y axis, and one is the rotary motion is possible, right? It may be a rotary motion is possible, and one is the translatory motion is possible, right? So if he joined here point A, so translatory motion is left. You can see if he is connected to point D, is connected to A, so translatory motion is losses. Only the rotary motion is possible. It means if any free link is connected to the joints, so we lost the degree of freedom, right? So you can see here that you can find out here that is L degree of freedom F equal to 3 into L minus 1 minus 2J minus H. It means you can see here degree of freedom L, there are 3 degree of freedom x, y, and rotary motion is there. Then one losses is there, right? So suppose degree of freedom x, y, z. In this case, we find out the formula F equal to 3 into L minus 1 minus 2J minus H. So where L is the number of link, J equal to number of binary joint, H is the higher pair. Total degree of freedom the L, so movable link is the L minus 1, and these are the resistance we fix up the joint that losses of this degree of freedom. So you can see here that is in this figure we can find out the degree of freedom. We can again find out the degree of freedom. We can find out the degree of freedom in this figure. We can find out the degree of freedom in this figure and find out the degree of freedom. A, B, C in the figure A, B, C, D, E, right? So you can see here that is one is the fixed link, 2, 3 and 4 is the 3, 2, 3, 3, 9 degree of freedom. Here you can find out the losses of the 1 degree of freedom is there. Here the losses of the 2 degree of freedom. Here the losses of the 3 degree of freedom. So we can see here the losses of the degree of freedom you can find out. And now we can say now let us consider for the planar mechanism L number of links in the mechanism. One link is the fixed, therefore the movable link is the L minus 1. So number of links we can say that is the L, one link is the fixed, so the movable link is the L minus 1, and thus the total number of degree of freedom will be the 3 into L minus 1 before they are connected to any other links. In general, the mechanism with one number of links connected by the j number of binary joints as a lower pair, that is you can say, and the higher pair. So you can draw the single degree of freedom, and if the higher pair the 2 degree of freedom of pair, then the number of degree of freedom of the mechanism, that is called f, or you can represent by n. So n equal to f, or degree of freedom f, or n equal to 3 into L minus 1 minus 2j minus h. This equation is called the Kutzbach criteria for the movability of the mechanism. So we will discuss again on the next lecture. We will discuss the different types of using this formula, find out the degree of freedom. So thank you so much. I hope you understand the basic criteria, Kutzbach criteria, planar mechanism, degree of freedom you understand. So thank you so much.